Hello grade 12s. We are continuing with the number patterns. Now we are going to look at how you can use the common difference D and the common ratio R to find the next two terms in any given number pattern. So let us say you are given this number pattern and they say find the next two terms. How do we find the next two terms? Remember what we said the last time. Whenever you are dealing with number patterns, it's always a good place to always start with finding the common difference or the common ratio. Remember that. So let us find. We say 4 minus 2, you get a 2. 6 minus 4, you get a 2. 8 minus 6, you get a 2. So we don't know what's going to be happening here, but we know that if we take this number minus this number, we are going to get a 2. Remember, the common difference is the same throughout when it's a linear pattern. So this is an example of a linear pattern. We are going to start with examples on linear. And this is example 1. So this and this is going to be 2. So this is where the common difference helps you. How? You say you just use this pattern, this waving pattern. It guides you on what is happening. So you say 2 plus 2, you get a 4. 4 plus 2, you get a 6. 6 plus 2, you get an 8. 8 plus 2, this number is a 10. 10 plus 2, this number is a 12. So example 2, find the next two terms in the given pattern below. Alright, so this is a linear series. As you said, it's a good place to find common difference first. 15 minus 1, 14. 29 minus 15 is 14. 43 minus 29. So here D was 2. Here D is 14. So we know that D is common throughout when it's linear on D1. 14, 14. So remember the wave pattern. 1 plus 14, you get a 15. When we're finding the common difference, we're subtracting. Now when you go back this way, you are adding. Okay? When you're finding the common difference, you're subtracting. When you go in this direction, you are adding. When you're going this way, you're subtracting. When you go in this direction, you are adding. It's always the opposite. 15 plus 14, you get a 29. 29 plus 14, you get a 43. 43 plus 14, that's a 57. And 57 plus 14, that's a 71. So you write your answers. The next two terms are, you always have to state this, 57 and 71. Okay, that's the same here. At the end of your calculation, you should state that the next two terms are 10 and 12. Okay, so with example 1, let's start with this one. 5, 19, 41, 71. We are supposed to find the next two terms. Right? So we know that we have to find the first difference. That's a fact. Okay, so let us find the first difference first. Foot 1 minus 19 is a 22. 71 minus 41, that's a 30. We don't know what's going to be here. Let's just put it there. We don't know what's going to be here. Let's put it there because of these blanks. So let us get to the second line. Since D1 is not the same throughout, it's not a linear, so let's find D2. So this becomes our new pattern. We do this as well. Let's do it again. 22 minus 14, we got an 8. 30 minus 22, we also get an 8. So this seems to be consistent throughout. So it's a quadratic pattern. So D2 will be the same throughout. So I write 8, 8. Now remember, the patterns, the wave patterns, they still work throughout. Okay. So 14 plus 8, you get a 22. 22 plus 8, you get a 30. 30 plus 8, so this number is a 38. 38 plus 8, that's a 46. Now remember, 5 plus 14 is 19. 19 plus 22, 41, and so on. The wave patterns continue. 71 plus 38, that's 109. And 109 plus 46, that's a 5. 155. Okay, so the next two terms are these two. Remember, this is the series. This will be the next two terms. 109 and 155. It's always a good place to find your common difference. So let's do that. 7 minus 4, that's a 3. 12 minus 7, that's a 5. 19 minus a 12, that's a 7. This minus this we don't know because of this blank box, so we just put another blank box and another blank box there. So this is not a linear. Let's continue and find the next set of differences. Okay, that's a 2. 7 minus 5, that's a 2. So it seems as if D2 is the same throughout, so this is a quadratic pattern. So if it's the same throughout, there's going to be a 2 here and a 2 there. 3 plus 2 get 5. 5 plus 2 get 7. 7 plus 2, that's a 9. 9 plus 2, that's 11. So we are done with this wave, which is dropping into these 2's. Let's do this wave, which is dropping into this line. 4 plus 3, 7. 7 plus 5, 12. 12 plus 5, 12 plus 7, 19. 19 plus 9, that's a 28. 28 plus 11, that's a 39. So the next two terms are, this is the sequence we're dealing with, so these are the next two terms, 28 and 39. Okay, still on quadratic, the last one. So we are supposed to find the next two terms, which are going to be in these squares. Alright, so this is the first step, is always 13 minus 6, that's a 7. 22 minus 13 should be 9. 33, this is just 11. 33 minus 12, sorry, 33 minus 22, it's 11. This minus that we don't know because if there's a blank box close to that, we also put a blank box. So this is not a linear. Let's quickly prepare for the second set. What do we do here? 9 minus 7. Oh, we are getting a 2 as well. Just like the previous example. 11 minus 9, 2, this minus this. Because these two are the same, this is a quadratic. The common difference in this line should be the same throughout. 7 plus 2 get a 9. Remember the wave. dropping into a difference, also the wave dropping into a difference. 7 plus 2, 9, 9 plus 2, 11, 11 plus 2, 13, 13 plus 2, 15. 7 plus 6 plus 7, 13, 13 plus this, 22, 22 plus this, 33, 33 plus 13, 46, 46 plus 15, 61. So the next two terms are, this is the pattern, and these are the next two terms, 46 and 61. How do you find the next two terms in a geometric pattern? For geometric, you are saying 20 divided by 10, 40 divided by 20, 80 divided by 40. When you are dealing with the wave pattern now dropping into the constant ratio, you are moving in this direction, which is opposite of that. So when you are going this way, you are dividing. Now when you are going this way, you are multiplying. Okay, take note of that. This way you are dividing, this way you are multiplying. So you are saying 10 times 2, get a 20. 20 times 2, 40. 40 times 2, 80. 80 times 2, 160. 160 times 2, 320. So the next two terms are 160 and 320. 1 sine theta, 1 minus cos square theta, sine cube theta. Now, before we find the next two terms, we have to simplify something here. This is sine squared theta from the trig identity. Sine squared theta plus cos squared theta is equals to 1. So you take this to this side, you are only left with sine squared theta. It's equals to 1 minus cos squared theta. So we need to make everything look the same. So this will look like 1 sine theta, sine squared theta, in place of 1 minus cos squared theta. Sine cubed theta. I think you can actually tell what's coming next, but let us deal with the geometric as we know how we should, as we are actually supposed to do, because there are marks for calculations. This is what we do. Sine theta divided by 1, get a sine theta. Sine squared theta divided by sine theta, get a sine theta. Sine cubed divided by sine squared, also get a sine theta. So our r is, always mention it, our r is equals to sine theta. So it should be sine theta throughout. Now, remember we said as you go this way, you are dividing. This divided by that, you get this. This divided by that, you get this. But when you're going this way, you are now multiplying. 1 times sine theta, you get a sine theta. Sine theta times sine theta, you get sine squared. Sine squared times sine, get sine cubed. Sine cubed times this, you get sine to the power 4 theta. Always remember to follow these steps, because sometimes you get something very complex and you need to know the procedures which to follow. Yes, I know these examples are very simple, but you need the procedures. Then sine to the power 4 times sine, you get sine to the power 5 theta. The next two terms are sine to the power 4 theta and sine to the power 5 theta. You need to state that. So this is the given geometric pattern, and you're supposed to find the next two terms. So this is the first step always. Now let's see. 2 divided by 6, you get a third. 2/3 divided by 2, you also get a third. 2/9 divided by 2/3, you get a third as well. So your R is a third, so it should be a third throughout. Okay, and as we said, when you're going this way, you are dividing, and when you're going this way, you're multiplying. We're saying 2 divided by 6, 2/3 divided by 2. But we want to go this way now, dropping into the ratio. So it's now 6 times a third, you get a 2. 2 times a third, you get this. So let's finish up. 2/3 times a third, you get 2/9. So 2/9 times a third, that will be 2/27. 2/27. Okay, and next 2/27 times a third, 1 times 2, 2 times 1, that's a 2. 27 times 3, that's an 81. You cannot reduce this, so it's 2/81. The next two terms are 2/27 and 2/81. So in this video, we've done how to find the next two terms. What about if they say find the 100th term or find the 1000th term?